Assalamualaikum and a very good day to my respected panels. My name is Nurfarhah Fasya Binti Mohd Khairi with student ID of B0518101004. I will present my project Sarjana Muda with the title of Evaluation of Navigation Performance of a Mobile Robot using Radio-Based Positioning. This project is guided under supervision by Dr. Muhammad Nazrin bin Muhammad. First of all, I would like to introduce regarding the Automated Guided Vehicle AGV and Autonomous Mobile Robot AMR. AGV and AMR may have some similarities, but there are also significant distinctions in terms of flexibility and capacity to self-navigate. But what is Automated Guided Vehicle or known as AGV? AGV is self-guided devices where it utilizes fixed navigation systems like cables or magnetic tape. The wire was induced with a frequency so that the AGV could detect and track the wire steered along the guided path as shown in the left picture. While Autonomous Mobile Robot, or known as AMR, is a system that functions in an environment that is both unexpected and unknown. It is a mobile robot include intelligent navigation features such as sensors and camera systems that allow them to identify and maneuver around obstacles. The problem statement for this project is the cost for AMR is quite expensive for the usage of small and medium enterprise. Robots are costly works, whether in terms of money or time required to make them. This is due to the high cost of hardware and software required to build a real robot, which varies depending on the types of robot. The second problem is the performance of AMR is quite limited with basic navigation. The frequency of the sonar used to allocate the position of the mobile robots used might facing a problem such as multipath issue. And the last statement is whether is it suitable to be used for SME. Therefore, the objective for this project is to investigate the potential of the ultra-wideband as positioning system for AMR. The second objective is to develop a navigation system for AMR based on the ultra-wideband positioning system. And the last objective is to evaluate the robot performance for indoor environment. The first scope for this project is the model of the robot will be based on the existing robot in the Advanced Mechatronic Lab. Then, the robot will be implemented with UWB to increase the performance for indoor environment. The robot that placed in the lab only have basic navigation system to maneuver it. In order to generate more ideas and information regarding this project, there are numbers of articles and journals has been reviewed. Some of it is by Botero Valencia and friends in the year of 2016 with title of a simple method to estimate the trajectory of a low-cost mobile robotic platform using an IMU. The input that can be extracted from it is Initial Measurement Unit, IMU, and Kalman filter. Next is by Chang and friends in the year of 2015 with Topological Indoor Localization and Navigation for Autonomous Mobile Robots. The input is the performance of AMR and the navigation of AMR. Besides that, the info for ultra-wideband, Wi-Fi, Bluetooth and Zigbee are retracted from journal titled A Comparative Study of Wireless Protocols, Bluetooth, UWB, Zigbee and Wi-Fi by Jinshan Li and friends in the year 2007. Cow and friends did a study on relative localization of mobile robots with multiple ultra-wideband ranging measurements in the year 2021. The input retrieved from it is the performance of UWB. And finally, the information about UWB tracking system is obtained from a study did by Canepa and friends in the year of 2017 titled Automatic Calibration of Ultra-Wideband Tracking Systems Using a Mobile Robot, a Person Localization Case Study. Next, we will continue with the methodology. The performance of a mobile robot is evaluated by testing the accuracy, precision, and repeatability in the navigation system of the mobile robot. The existing mobile robot will be implemented with UWB and the mobile robot's performance is analyzed. As shown at the right side of the slides is the Kalman filter framework for AMR. The Kalman filter architecture will combine the location data from various sensors. As shown in the slides right now, this is my flowchart for this project to navigate the AMR. A detailed explanation about the method will be explained in the next slide. As shown in the slides right now is the hardware known as Track 1000 Decawave. It also known as Two-Way Ranging RTLS IC Evolution Kit. Decawave's DW1000 Ultra-Wideband Transceiver Integrated Circuit is used in this kit. It consists of EVB1000 PCB, UWN antenna, EVB1000 stands, and DC power leads, which required 4 pieces for each of the parts respectively. It also contains of 3 pieces of 1.8 meter USB cable and a piece of 60 cm USB cable. Finally, the most important thing is the quick start guide for the Track 1000 Decawave. Now, move on to the setup of the UWB, which the first step is to connect the antenna to the EVB1000 PCB. Then, mount the EVB1000 anchors depends on the type of experiment that will be performed. It is very important to ensure the antenna is 15 cm further from the wall. Moreover, ensure metal object is below the antenna plane. The ground plane of the antenna is considered to be the top of the SMA connector under the antenna. Next, EVB1000 can be powered either by using an external DC power supply or USB power supply to power it up. Then, configure the EVB1000 and finally the EVB1000 will display configuration on the screen. Time difference of arrival TDOA is a method which is used for geolocating radio frequency sources. Hence, it is one of the navigation technique for wireless sensor network for this project using UWB. When receiving the signal at 2 reference points, the arrival time difference can be used to measure the distance difference between the target and the 2 reference points. Meanwhile, trilateration uses the measured distance to measure an object's position from at least 3 fixed points in 2D space or 4 fixed points in 3D space. Therefore, the difference can be calculated by using the first formula on the slides. However, the equation can be modified in the form of hyperbola by using nonlinear regressions. Hence, the target's positions can be obtained from the intersection of the signal. Now, let's look at the experiment setup for this project. Basically, these experiments will be held in indoor environment. The tag will be held by using tripod and set the height according to the same height of the mobile robot. Then, set up the anchor and tag into the positions of the required distance, which are 20 meters, 40 meters, and 60 meters. After that, simulate the mobile robot and get the reading distance data shown in the Decawave software. The Decawave software is used to monitor the positions of anchors and tag based on the reading from each device. Based on the data collected from previous process, it will be used to calculate the accuracy and the error of the mobile robot's performance on navigation system used. The performance of a mobile robot is determined by evaluating the accuracy, precision, and repeatability experiments on the mobile robot by using UWB as radio-based positioning. The purpose of the experiment is to determine whether the mobile robot that has been implemented with UWB can follow the commands with high accuracy and precision. On top of that, accuracy shows how close the value or measurements to the true value, while precision shows how close repeated measurements are to each other. percent error is often used to describe the accuracy of a measurement. The formula used is as shown at the bottom left of the slides. For an example, the mobile robot will travel to a certain path and position. The mobile robot might stop at an offset point from the original point, which shows that the accuracy of the mobile robot by obtaining from the percent error. The final experiment is to evaluate the repeatability of the mobile robot. Repeatability is the closeness of agreement between several positions reached by the robots and effectors for the same controlled position repeated several times under the same conditions. Therefore, it indicates the robot's ability to return to the same position. Thus, the purpose of the repeatability is to see if the mobile robot able to return to the same position after go through a path based on a predetermined distance. The table consists of distance traveled, which in meter, the number of attempts, calculated distance, average, and the percent error. The distance set for this experiment are 20 meters, 40 meters, and 60 meters, which all three of it will have a total of 3 attempts for each of the distance traveled in order to get the average value. And finally, we will see the percent error, which can be used to evaluate the mobile robot performance by using UWB as radio-based positioning. After all of the data collected for this project, the expected result is the output results for the data reading is expected to be almost 90% accuracy. It is also expected to be able to achieve the error below than 10% for the accuracy, precision, and repeatability. I would like to express my gratitude to my panels for your time to evaluate my PSM presentation. That's all from me. Thank you.